Hi everyone, today we're going to build a demo that will visualize a vector field. So we've done something similar with particles, where the particles kind of follow the cursor, and today we're going to visualize vectors, which are basically like arrows. Those arrows are going to rotate to match the location of the cursor. Right, what we need is a simple application to start with, and then we'll go from there. Create content. Just use normal pane, I guess. That should do it. For some reason IntelliJ decided to index everything. All right. Routes, yeah, sure, import this, and do we need canvas? I don't think so, because we'll probably add arrows as nodes. So there are various ways you can draw an arrow in JavaFX. You can use a Unicode character. You could use what I'm going to use, which is just draw 3 lines. That will give you a representation of an arrow. You could use an actual image, load it and so on, but a node is fine, I think. So arrow extends parent. We are going to have 3 lines, I think. That should do it. So line middle, because that's the middle line, and then the top line, the bottom line. New JavaFX line, it's this one that we need, and that takes, it needs X, Y, the start and end points. Okay, so we go from 0, 2.5. Suppose our line is, right, we'll probably use something like 5. We'll see, we can tweak it as soon as we can see the line. So root get children, add new arrow. I want this arrow somewhere here. Set translate X 100, set translate Y 100. And that line basically goes like this horizontally. So it ends up being something like this and that. And then we need the top one, line top. So I'm going to draw the line so that it faces the right hand side, because that's where the 0 degree angle is located, at least mentally. Because if you're getting your assets into the program, into a game or something, and they face right, then that simplifies the whole rotation thing. Because if you need to apply transformations like, you know, rotate by 90 degrees, then you simply rotate it by 90 degrees and it just works. If it faces a different direction, then you need to kind of offset by an extra transformation rotation. Right, so line top, that needs to go from the rightmost point and upwards. The rightmost point is 20 and 5. It needs to go to the left, so it's something like this, and then up, something like this. The bottom line is kind of similar. It starts off at the same point, but it goes downwards. So instead of 2.5, it's probably 7.5. Let's run and see, and then well, that won't actually draw anything. Do you know why? because we haven't added anything. These are just objects in memory, that they're not attached to anything. Add all, line mid, line top. There we go. That should fix it. We have an arrow. That is actually a pretty good arrow. Just need to scale it up. I also need to set size. Let's go HD on this. And then this, I don't want to play with ratios because I know these are now looking really good. I need to multiply it, or I need to somehow scale it. And scaling might break rotation in the long run. Can I do an internal scale, something like this? Then just multiply everything by this scale. Will this work? It works in a lot of cases. And that wouldn't really interfere with the actual transformations being applied to the object because there are none. These are actually kind of internal scaling values, meaning these are the absolute values. We're not doing anything, we're not applying any transformations via JavaFX. Yeah, that looks fine. So imagine now a field of these arrows. So we're going to have lots of them. By lots, I mean however many we can fit. And if they rotate towards the cursor, then that's this demo completed. In terms of practical sense, you probably won't be able to use this in many applications that you're going to build, but at least you'll know how to do it when the time comes. Should it come at any point, which means we need lots and lots of arrows. So for Y, this is 720. For X, this is 1280. We probably want to divide this number by, so 20 by 2.5, right? That gives us 50, and that's the X length of our line. And then the Y length is, I think, that one, because that's the largest number I can see that's multiplied for the Y value. So let's make that 8, let's make that 3, 24. So divide this by 24, and then that by 50. Kind of, and then we'll see how this works. And we're going to construct an arrow. We're not going to set these hard-coded values. It's x multiplied by 50, because that's the thing that we're dividing it by, and y multiplied by 24. And then added to the scene graph. That'll give us something. That looks reasonable, I think. There are no spaces because we haven't added any offsets. In terms of this being a field, it is a field, it looks like. Now onto the interesting bit where we rotate these things. because these are objects, as in these are nodes, ultimately, it simplifies the whole process because we no longer need to deal with any kind of transformations in terms of the canvas. We don't need to apply anything. We just say, this object needs to be rotated by this angle. And then we do that for every single object in a loop. So that kind of makes it almost trivial. We need to do that constantly, meaning we need to have some kind of on update method. And for that, we need an animation timer, as per usual. Animation timer. And we should always remember to start the timer before you do anything. On update, so that's going to be called every frame, and every frame we simply recalculate where the cursor is and rotate every arrow towards the cursor. Right, how do we get cursor's position? The easiest way, I think that's how we did it previously, right? Just get the scene, attach some kind of handler, set on mouse moved. I think that should do it. And then that gives us the event. And then we simply capture mouse X, mouse Y. That'll do it. And then we rotate. So we need to go through all items. Root is not accessible, but then we don't really need the root. We need the arrows. So let's have a list of arrows. Oh, we want to construct a new one. And then arrows are going to be populated here, which means on update, we can just run through each arrow, arrows for each, and then we'll do the math. Now, how do we rotate? Rotation is in 2D, well, it's actually quite simple. We need to obtain the vector from where the point is that you want to rotate, and to the other point that defines an angle in relation to the x-axis. So this is again where it really comes all together. If you place your assets so they face right, meaning the 0 degrees, then when you rotate them, the vector along which they're facing in relation to the x-axis is going to form the angle that you need. So whether you know the angle or you know the vector, you can obtain the other value. So if you know the angle, you can calculate the vector. If you know the vector, you can calculate the angle. In our case, we know the vector, we don't know the angle. So we can use the vector data, the x and y components of a vector, to calculate the angle and then ultimately rotate the arrow. Because the end call is going to be something like this, set rotate and then provide the angle, which means we just need to calculate the angle. And in case you're wondering, the axis along which we're rotating, it's the Z axis. In 2D, I think every rotation, every meaningful rotation will be happening around the Z axis, which goes from your eyes towards the screen. And that's how you rotate. You can only rotate this way, which would make sense. In 2D, any other rotation, which is like along the x-axis, which is like that, and along the y-axis, which is like that, it is not very meaningful. You're going to end up with very odd-looking visuals. So it's a tan to y over x, and y and x we obtain from the vector. And that vector is the difference between the 2 points. One point is where the cursor is, The other point is where the arrow thing is. So we need Vy and we need Vx. Vy is the difference between the mouse location and the arrow location. So translate x and mouse x minus a translate. No, that's x and this is y. And we simply put the values in. And a-tan2 gives you y over x, gives you the angle. Now we need to be careful here because some APIs return angles in degrees, some in radians. Others expect in degrees, the others expect in radians, as in when you're passing in as an argument to a function. A-tan2 will tell you that it returns I'm pretty sure it's radians. I think it'll be just much easier to convert that and then go from there rather than reading through the entire documentation, because it says that it returns theta compared to the point in polar coordinates. So that has to be in radians, right? And then there's a nice method in the maths class that is called 2 degrees. It takes radians and then converts them to degrees. That's what we need. Now, what I'm thinking about is the sign of this, because in real world maths, you go this way and your y-axis goes up. In JavaFX and in some other frameworks, the y-axis goes down, so you have to flip it. Let's try that. We might need to flip it. Kind of works. There's something weird about it. I think it has to do with the it's either the sign that I need to change, or I need to change the origin, the pivot point of the rotation, because depending on where the pivot point is of the object that you're rotating, you're going to get different results. But I think it's the minus sign that I need to flip back, because you can see that although my cursor is down here, the arrows that are above it are pointing up. They should be pointing towards the cursor. So what happens if I do this? Yeah, that's better. And you also need to take it into account that an arrow in itself as a visual graphical object is not a point, but we're treating its coordinate as a single point. So translate x and translate y. So depending on where the cursor is, if it's very close to an arrow, then the arrow itself may not render correctly. So you want to check how you're going to interpret that, because our arrow is quite long, which kind of exacerbates the situation. But we can reduce the length of an arrow, which would probably make things a bit simpler. So we can do something like 15. Wait, no, that's not it. Oh, right, it is 15, 15 here, 15, that goes down to 12.5. So it's going to be a shorter arrow. And then the closer it is to a single point, the more accurate your visualization will be. But this is okay. Now you also want to probably figure out a way to kind of strengthen the position of a cursor. Maybe draw a circle around it, or actually let's do that. Yeah, as a final thing, we're going to add a circle that just kind of follows the cursor so we can see where it is. Don't think we need another class for it because there's already a class called circle. Let's add our circle over here. It's going to be something like 10. This is the radius, color, I don't know, red, possibly. Then root get children, add a circle, and then we need a reference here somewhere so that we can update it. And then on update, the circle needs to simply follow. Center X should be mouse X, and center Y should be mouse Y. So you can see the actual logic is reasonably straightforward. If you've done any kind of vector maths, then that's straightforward. Yeah, so you can see the circle, and then the idea is that everything points to that circle. At least the arrows that are far away. Right, hopefully this has given you some ideas regarding how you might actually use it in a practical application. I can't think of any at this point. But at least in terms of the rotation and visualization, that might be helpful. So the most important thing here is basically this. So whenever you need to rotate something, if you already have the angle, then just use this method. The method to use when you need to change the pivot point is slightly different because you need to apply transformation. So you'll need to get the transforms list and then add a rotate object. But if you're rotating it along kind of the center of the node, then set rotate is just fine. If you don't know the angle, but you do know the vector, then use the vector's x and y values to submit them to a tan 2, convert them back to degrees, and then use the degrees as your angle. Right, on that note, thanks for watching, and I'll see you later.